Hello students, our last video was about Boyle's law. I hope that is clear for all of you, and I also hope that you have done the two numericals that were assigned as your home task. Now let us move to the next law that I had already given a briefing about, that is Charles' law. Now just like we had temperature constant in Boyle's law, in this case our pressure is constant. So at constant pressure, volume of a given mass of a dry gas is directly proportional to its temperature. Now students, I have already explained to you what does the term given mass of a dry gas mean, so I will not repeat it in my video once more, but just remember again, these are our keywords. So the keywords include constant pressure, volume of a given mass of a dry gas is directly proportional to its temperature. Needless to say, since it's a law, if you are asked to write the statement or you're asked to state the law, it should be a word by word statement, otherwise it will lead to deduction of marks. Now moving on to the mathematical expression for Charles' law. Now what it says is volume is directly proportional to temperature. So V directly varies as T. Now you already know this is my proportionality sign, and since my pressure is constant, I have totally ignored it in my mathematical calculations. So if I want to bring in an equality sign, I have to multiply the right side with a constant, which is again K. K is my constant. So that brings me to V is equal to KT. If I want to bring T towards this side, V by T is equal to K. So this is also one form of Charles' law. Now moving on, just like we did for Boyle's law, if my initial conditions of a particular gas is V1 and T1 and the final conditions are V2 and T2 at constant temperature, therefore V1 by T1 will be equal to constant, as well as V2 by T2 will also be equal to that constant. Please understand students, there just the way I told you that come what may, the product of pressure and volume will be constant for Boyle's law. For Charles' law it is come what may, the V1 by T1 or V by T, volume by temperature term for a gas will always be constant. So whatever importance PV had over there, the same is the case with V by T over here. So if my V1 by T1 is equal to constant K and my V2 by T2 is also equal to constant K, I can bring in my final Charles' law mathematical equation as V1 by T1 is equal to V2 by T2. This is my mathematical equation that I will use for all numericals based on Charles' law. I hope I am clear. So if you are asked to state Charles' law, please ensure that your statement is correct. And if you are asked to write down the mathematical equation for Charles' law, please ensure you are writing this. Clear? Can I move forward? Now, one more thing that we need to know, when I am talking of numericals on the basis of Charles' law, the temperature factor comes in. Please remember, temperature in the question, if it is given as degree Celsius, I have to convert it to Kelvin for my calculations. Any calculation in degree Celsius or Fahrenheit is not allowed. All calculations always in Kelvin. So how do I convert it? So suppose I am given 25 degrees Celsius. Needless to say, I have to convert it to Kelvin for doing my sums. So it is 25 plus 273. Whatever that comes to is my Kelvin temperature. This is just an example. This doesn't mean it will be the same temperature everywhere. This is just an example, students, to tell you that ensure that always whatever calculations you are doing, it is always in the format Kelvin format and never in degree Celsius format. Now moving on, if I want to plot a graph just the way we did for Boyle's law, now let's see what's my first graph, V versus T. Now volume and temperature are directly proportional to each other, so obviously it will be a positive slope graph. But please note students, I have also extended my graph towards the negative x-axis to make you understand that temperature can also have a negative value. Pressure, volume can never be negative, they can never be zero, but temperature, there is no problem like that with temperature. Temperature can always have a negative value. The next one, V versus 1 by T. So if V is directly proportional as T, V versus 1 by T will be an inverse sloping or a negatively sloped line, just the way you are seeing here. Hopefully this is clear. Moving on to numericals, this will be your assignment. I will not show you any more. I have already shown you one sample numerical in Boyle's law. You will follow exactly the same procedure, exactly the similar kind of statements to do these particular numericals for Charles' law. Now, giving you small hints for this, what does this say? At constant pressure, a gas occupies 5.3 liters at minus 23 degrees Celsius. Mind you, this degree Celsius has to be converted back to Kelvin. Calculate the final volume if the temperature is 45 degrees Celsius. Again, this has to be converted to Kelvin. Put it in the formula V1 by T1 is equal to V2 by T2. Find out your answer in liters. Ensure that your units are all written. Ensure that you are showing proper calculations. Also, do not forget that this is a minus 23 degrees Celsius. So when you convert it to Kelvin, do it accordingly. Clear? The second question that I have put up. At constant pressure, a gas occupies 24.7 ml at 0 degrees Celsius. Calculate the final volume if the temperature is reduced to half of its original value. Now students, do not think half of temperature will again be 0. Don't ever think that 0 by 2 will be 0. No. 0 degrees Celsius again has to be converted to Kelvin, and then you will find out the final temperature, which is the half of initial temperature. Put it in the equation V1 by T1 is equal to V2 by T2 and find out the answer. Am I clear? I hope this will be clear for all of you. Once you do the Boyle's law, Charles' law becomes very easy. So these two numericals are your assignments from this video. Thank you.